All right, everyone, I'm going to get started. So we finished up section 1.2 yesterday, and I assigned a little homework assignment, and the problems from that homework assignment mimicked the examples that I gave in class. So does anyone have any questions about the section 1.2 homework? So these 5 problems that you're seeing on your screen now. Any questions?
I have one.
Sure, what do you got?
Number 19. Can you do it?
Sure, absolutely.
Thank you.
All right, let's see. So back in section 1.2, number 19. So is this the computers on sale problem?
I think so.
Yeah, that's the one. So computers on, and this is in section 1.2, so it's the word problem. A computer's on sale for $11.92. So let's just call that the sale price. We know that's $11.92. I'll just call that S. If the original price was reduced by 20%, so there's some reduction percentage, we'll call that 20%. But really, anytime we have percentages, we have to put that in decimal form. So 0.20 would be 20% in decimal form. I guess I'll call that R. And then the original price, we don't know what that is, so we'll call that P. And they want us to find what was the original price of the computer. All right. So this goes back to, it's going to be like one of the, I think it's the first example I did here. We're actually going to be looking at this same equation, right? So if you have if you're buying something, right? So let's say, all right, you're buying this computer. It costs, P dollars, and you're getting 20% off. You would subtract from that whatever 20% was of that original price, and that's going to be equal to our sale price. Okay, so now, let's see. We know what the sale price is, $11.92, and this side over here, right? It looks like there's nothing in front of the first P, but really there's a coefficient of 1 here. So we're doing 1P minus 0.2P, and we get 0.80P. And then we'll just divide that sale price, $11.92, by 0.80, and it should come out to be $14.90. That'll be the original price. So does that make sense now that you're seeing it again?
Yeah.
Is that good? All right. So any other questions from this section?
Can you do 26?
Sure. So let's see what we have here, number 26. This is an investment problem, right? So what we're going to do is we're going to use the same formula from the problem we did in class. So this was A equals P plus P times R times T. So just to describe this again so everyone's familiar, P was your original investment, right? R was I think the interest rate that you were going to be applying to that investment, and then T was how long that investment would be going for, and then A was the end balance on whatever you initially put into the account. So what they want to do in 26 is determine the amount of money that was invested. So in 26, we're looking for P. Okay, we're looking to find what P was. If, let's see, what else did they tell us? Assuming that 2482 resulted from a 10-year investment at 7%. So we know T is going to be 10 years. The result is A in this case was 2482, and the interest rate was 7%. But again, for 7%, if we want to plug it into this equation, we're going to do 0.07. All right, so let's see. So it's a linear equation because we only have one unknown. So let's plug in everything we know. I should have moved these over a little bit. Actually, if my fancy, oh, that was terrible. Ugh, sorry. There's a button you can click on this. Look at that, and then highlight it, and then I could slide that sucker right over. Look at that. That's a little bit better. So if I plug in 2482 for A, I don't know P. And then we have R times T, so that's going to be 0.07 and we're going to do times 10 years. So 2482 P plus, now 10 times 0.07 is going to be 0.7, so this is going to be 0.7 P. 2482. So again, this P right here really has a coefficient of 1 in front of it, so it's 1P plus 0.7 P, so it'll be 1.7 P. And then we'll just divide 2482 by 1.7, and we should get 1460. So the original investment was $1,000 and $1,460 invested at a rate of 7% for 10 years, and then the balance at the end was $2,482. Okay, anything else from 1.2? Okay, because we have a quiz today, I wanted to also offer up a few minutes. Does anyone have any questions on section 1.1? I'll be happy to go over a problem or two there. Does anyone have any questions from 1.1?
I actually do.
What do you got?
47 from the homework.
Let's see, 47. So I'm going back to 1.1. And we're looking at 47. Okay, perfect. So 47 is a rational expression, right? So let's see. So I'm putting this example at the bottom of 1.1. So this is number 47. Let me write it all out here. We have 1 minus x. Is this Hunter, by the way?
Yeah.
All right, just answering the question from your email then. Perfect. Okay, so for these problems, the easiest way to do it is going to be taking all your denominators, okay? So in this case, you have a 4, a 2, and really the denominator of this 3 is a 1, but obviously we don't have that written there, and then you have an 8. So what you could do is, if you're not really good at finding the least common denominator, you can definitely find the greatest common denominator by just multiplying them all together. So in this case, if you did 4 times 2, which is 8, 8 times 8, you'd get 64. Okay? So you could multiply this by 64. And let's go ahead and do that. But does anyone else know what number would also work that would make this problem easier? What could you multiply all of this by?
16.
You could do 16, but couldn't you also do 8? Right? Since 4 divides 8 evenly and 2 divides 8 evenly, the least common denominator is 8. So you could do it with 8, but let's go ahead and just say you didn't see that right away. Let's go ahead and do 64. So I'm going to multiply this sucker by 64. All right, so how many times does 4 go into 64? Because I'm working on this first rational expression. 64 divided by 4, we get 16, right? So this will cross off here. This will be a 1. So then this first term here will be 16 times 1 minus x. All right, now we'll go to this next one. So when I divide 2 into 64, I get 32. Then I'm going to do 64 times 3. I get 192 because the denominator is already 1. And then obviously this 8 goes into 64 8 times. So it's going to be minus 8 times 2 times x plus 1. All right, so that eliminated all of these fractions. Now it just becomes a linear equation that we have to go ahead and solve. So I'll just go ahead and do all this distribution. And again, with these bigger numbers, and you're allowed to have a calculator, so it really shouldn't be too much of an issue. So we're going to have minus 16x minus 16. So now it's all about just combining all of this stuff together here. So let me just combine some things on the left. So we're going to have 144x, and then 16 plus 32 plus 48 is equal to, what's 192 minus 16 is 180, so 180 minus 16x. I'm going to put that 16x on the left-hand side, so I'll add to both sides. So then this will have a 160x. And then on the right side, it'll be 180 minus 48. We get 132. So you have 132 over 160. The big thing here would be just actually trying to simplify it a little bit. So the final answer here, just to give you an idea, this was 47. It's 4/5. So let's see, 132. So if I divide everything here by 33, so if I did 132 divided by 33, I get a 4. And then if I did 160 divided by 33, I don't get 5. Did anyone see a math error I made?
192 minus 16 isn't 180.
Where is that there? Oh, see, that's it right there. 192 minus 16. Thank you. So that's a 176 right here, and that's going to help me immensely because then I'll do 176 minus 48. So that's is this a 128 then? So then 128 over 160. So 128 divided by 4. So we should be able to do 160 divided by 32. There it is. So if you divide both of these by 32, you get 4/5, which is the final simplified answer. But all of these bigger numbers become smaller if you would have seen that you could have done 8. Or whoever mentioned 16, you also could have done 16. But if all else fails, if you can't find that least common denominator, just multiply them all together like we did here, and then do everything by 64, and then if you don't make a math mistake like I did. But just as an example, this is not a bad time to mention this. If somebody made the mistake like I did, and you showed me all of this work, I'm not going to take a ton of points off for this problem because all it was a simple subtraction error. Okay? All right, so anything else from 1.1 that we'll just a couple more minutes and then I'll move on. Anything else from 1.1 people would like to see?
Yeah, can you do one more domain problem?
Sure. Let's see. Where the heck are they? Okay, so how about... So are you good with 15 and 17? Because I believe they're the ones that I assigned.
Yeah, they're fine.
They're fine. I'll just make one up. So let's say we had, I'm trying to think of a good one here. I also don't want to confuse you by making it super complicated. Let's see. Let's just do something like this, okay? This is very basic, right? You don't have to worry about the right-hand side of the equation, right? Because you could plug any value of x there and that's real. The left-hand side, again, when you have the denominator of a fraction, it can't be equal to 0, right? So what value of x makes it 0? Well, it would be, you can't have x be equal to -5. So what you could say here in words is all reals except x equals -5. Now, if you wanted to write that in interval notation, you would do, remember, you have to use a parenthesis for infinity. So -infinity all the way up to -5. Now, again, we're going to use a parenthesis here again because we don't want to include -5. And then this big symbol is the union. So it's going to be that interval and this other interval from -5 all the way up to positive infinity. So that's if you have fractions, okay? If you had something like this. Now you have your square root, all right? So we also don't want to have imaginary numbers, which is actually something we're going to get to today. We do not want to have imaginary numbers in our domain. So we don't have to worry about the right side, x minus 5, all reals applies there. But over here, we have to have 1 plus x. So whatever the radicand is, whatever's underneath the square root, that has to be greater than equal to 0. All right, so that's all you do when you have a square root. You take the thing in the square root and put it greater than equal to 0, and then just solve that inequality for x. And they're never going to be super complicated. So you're just going to move that 1 over to the other side, which makes it negative. So that's x greater than equal to -1. So you would say all reals except all reals, and you could, explain this however you want in your own words, all reals where x is greater than equal to -1. Now in interval notation, okay, since it's greater than equal to, we want to include -1, so we would use a square bracket. And then we would, since it's greater than that, we can go all the way up to positive infinity, and that would be a parenthesis. So does that help just kind of review that?
Yeah, thank you.
Sure. All right, what do we think? We're okay?
Could you go over number 15?
Sure. 15, we have, oh, that's a good one. So 15, they give us two rational expressions. Now, in the very first example I just did here to review, only one side of the equation had a fraction, right? So we didn't worry about the side that didn't have a fraction. But in this one, we have two fractions. So let's just start with the one on the left. In order for this side to not be undefined, y cannot equal 1. Right? If y was equal to 1, we'd have a 0 in the denominator. We can't have that. On this side, if y was equal to -2, again, it'd be undefined. So if you wanted to write this domain in words, we would be all reals except y equals 1 and y equals -2. But the interval notation is going to look a little bit more complicated because now we have two values we can't include. So again, you're always going to be starting at -infinity. So here's the interval notation. You start at -infinity, then you go up to the smaller of the two numbers. So the smaller of these two numbers is -2. So you go up to -2. Just think about where those numbers fall on the number line. So we don't want to include -2, so we have a parentheses. We'll union that with, then you start at that same number, -2, go up to the following number, which is 1. Do not include it. And then union that with 1 going up to positive infinity. So the interval notation looks, it's just a little bit larger because we have to worry about two values. Does that help?
Yes, so we don't have to solve that equation, like solve for y?
No. If all they ask you is to determine the domain, this is it right here. That's it.
Okay, thank you.
Sure. We're good? Anything else? Cool. All right, so that is, that'll be a very helpful review for the quiz that we'll take at the end of class today. Let me just quickly see if anyone just popped in. We were almost all here. Let's see. Okay. Kiros here. How about Eamon? Is Eamon here? All right, no Eamon. Okay, so we're still, you can still see my notebook. So I'm going to go back to section 1.3 and just quickly review what we had covered the other day. I don't know why I always take forever to pick a color. It's weird. All right, so section 1.3 was all about quadratic equations. So these were polynomials of degree 2, and now we're learning how to solve equations involving those. So this is going to be important for the last method to solve these types of equations today, and it's the standard form. So we have this ax squared plus bx plus c equals 0. We're going to always want to make sure that we're in that standard form. So the first method was solving by factoring. Probably the easiest method just because we've spent a ton of time on factoring in the P sections. So essentially you just factor the polynomial, factor the quadratic equation, and then when you get to this point here, where you have your two binomials, you just set those equal to 0, get whatever values they are, and then your solution set just becomes the solutions to those simple equations. And we just went through a couple different varieties. All right, hopefully they're not too bad. Then we have the square root method. And they were pretty simple too. It's when you have a quadratic in a non-standard form where you really couldn't factor anything, but you can isolate, you could put something on one side of the equation that is squared and put everything else on the other side and then basically square both sides. So like in this example here, you had this binomial x minus 4, it was squared, set it equal to 7, then you just take the square root of both sides. But just remember, when you take the square root of a number, like over here with this 7, you really have two roots, right? A positive and negative root. So you end up having this plus or negative sign, which indicates that there's still going to be two solutions to that quadratic equation. So, I went through the steps. You isolate whatever term is squared. It could be a single variable or it could be a binomial. Then you square root both sides and then simply solve for x. The third type was completing the square. Now this had a few more steps. So I gave you this example here. And do you think it'd be useful if I walked through another example?
Yeah. Yes, Professor.
Sure. Let's do another one. All right. I don't want to repeat one I already did. So let's see. I did that one already. How about, here, let's do this one. This is another example I have. We have 4x squared minus 24x plus 25 equals 0. Now, of course, you could always try to factor this, but I don't think this one's gonna work. So just because I'm looking at the answer and it's definitely not gonna work. Okay, so what do? Here are the steps. First thing you want to do is isolate, as it says here. Oh, it's too far away, right? We'll just look at them real quick. Isolate the x terms, okay? Which means we're going to keep the 4x squared minus 24x over here, and then I'm going to throw the 25 to the other side, which makes it negative. The next step was to make sure that the coefficient next to the x squared term was 1. So in this case, it's not. Okay, so we're going to divide every term in the equation by 4 to get rid of that term there. So I'm going to do x squared, right? 4 divided by 4 is 1. Negative 24 divided by 4 is negative 6x. And then on the right-hand side, there's really not much I can do. I have to leave it as a fraction. So negative 25 fourths. Okay. Now, the next thing is to determine the value of b, right? So in this case, what's b? B is going to be 6 in this case, right? Like this is the b term right here. And what you do is you find b divided by 2, which is 3. And then you take whatever that b divided by 2 term and square it. So in this case, this one's pretty simple. We just get 9. So this number here, once you determine it, so you have the b term, square it, you're going to add that term to both sides of the equation. Because the left side now, when you do that process, right, this is going to be one of those perfect squares, right? Because you could take the square root of x squared, get an x, take the square root of 9 and get a 3, and then because this is a negative 6x, we know that it's going to be x minus 3 and it'll be all squared. All right, so that's our goal, is to get the left-hand side to be a binomial that's squared. And you might have to do some, fraction addition over here. So how many fourths are in 9? I'll just put that over here, right? Isn't that 36 fourths? Is that true? All right, 36 divided by 4 is 9. So it's like we're doing negative 25 fourths plus 9 fourths, which gives us a positive 11 fourths. So you're going to have to do a little fraction and math in some of these. All right, what's the next step? Well, once we get to this stage, now we're reverting back to method 3 where it's the square root method. So we take the square root of both sides. This becomes x minus 3. And the right-hand side becomes, we're going to have a plus or minus the square root of 11 over, now I could take the square root of 4, so I get a 2. All right, and then it's just solving for x at this point. So here's what we'll have. We'll have 3 plus or minus the square root of 11 over 2. And you could leave the answer as that. So that's completing the square. All right. Now, so there's all those three methods. So those three methods only work for certain types of quadratics. Method 4, which is the last method for this section. So this is method 4, is using the quadratic formula. Now, what's good about the quadratic formula is you could use it on any quadratic, no matter which you have, as long as it's in standard form. So our standard form, as a reminder again, ax squared plus bx plus c is equal to 0. So what you could do actually is you can go through the completing the squared method on this equation and leave it all in variable form and end up getting this as the solution for x. So here's what it is. It's negative b, and I'm sure you've seen this before at some point in your life, negative b plus or minus the square root of b squared minus 4ac over 2a. So all you need to do to solve a quadratic equation with the quadratic formula is identify a, b, and c, and then plug those values into this equation. Now, I'm going to give you a little table over here because the type of solution you get depends on what goes on underneath that square root. And for this particular formula, we call the thing underneath that square root, which is really the radicand, but since it's an expression, we call it the discriminant. You may have remembered that term before. So we're looking at this value of b squared minus 4ac. I don't know why I did an a there, right? Now, if that b squared minus 4ac is less than 0, what's going to happen to our answer? So the result then, the result of that b squared minus 4ac being less than 0, which means we're going to be trying to take the square root of a negative number. So we would say the result is imaginary. And in this section, we're not going to have any imaginary results because we haven't even covered that yet. Now, if b squared minus 4ac was equal to 0, we're totally allowed to take the square root of 0, right? That would just mean we have one real result. But if b squared minus 4ac was greater than 0, we'll have two real results. And we really can never have more than two results because for a quadratic formula of degree 2, there are only two answers. So this is what could happen in these problems. But for this section, we're only worrying about these two. You could either have one result or two. So let's go ahead and let's try an example. And you might as well do this. Let's go ahead and do this 4x squared minus 24x plus 25 equals 0 and see what happens. So let's try that using the quadratic formula. So here's our example, and we'll see if we should get the same answer. So 4x squared minus 24x plus 25 equals 0. Just make sure that's the same. Yep. All right, so the first thing you're going to want to do is identify a, b, and c. So a in this case is 4. B, now you have to include the sign, so it's negative 24. And then c is positive 25. All right, seems easy enough. So let's plug everything in. So the first term is negative b, so I'll write this out the first time just so you can see that you have to include both negative signs there. Plus or minus the square root of, so we're going to square b minus 4 times a, which is also 4, times c, 25, all over 2 times a, which is 4. And again, it just becomes an arithmetic problem here. So this first term here, negative 24, becomes a positive 24. Now we're going to have some numbers here to work with. I don't know what 24 squared is off the top of my head. It's 576. But again, you can have a calculator. And then we're going to do 25 times 4 times 4. That's 400, so minus 400 all over 8. All right, so far so good. So let's see, 24 plus or minus, so 576 minus 400 is 176. All right, so we have to do a little, I think this was in section P6, right? We can't leave it as 176, right? We could definitely figure out a number here. So it turns out that, just to expedite things, 16 times 11 is 176. So this could become the square root of 16 times the square root of 11 over 8. Let's simplify this a little bit more. 24 plus or minus 4 square root of 11 over 8. And then the last thing to do would be to, we could divide everything by 4, right? We could divide this by 4 and get 2. We could divide this by 4 and it's 11, or I'm sorry, just a 1. And then this divided by 4, you get 6. So we have 6 plus or minus the square root of 11 over 4. Or I'm sorry, over, this should be 2, my bad. So if we go back to our answer up here, 3 plus or minus square root of 11 over 2, that is the same thing as here, because if I split this fraction up, this is the equivalent of 3 plus or minus the square root of 11 over 2. So you could do that same quadratic by completing the square, or you could use the quadratic formula. Now the quadratic formula, you see that it kind of took a while because I had to go through all the steps of doing all of the multiplications, square roots, and that sort of thing. But you always will get to the right answer. All right, I'm gonna do another example, but I wanted to stop for a second and ask if anyone had any questions so far. Okay, seeing none, I'll do another example here. I'll do a little simpler one. That one was just, I wanted to show you that you get the same answer with the same quadratic formula. So let's do a little simpler one here. How about yeah, let's try this one. I'm not sure what the solution's going to be. Maybe it's not simpler. Those numbers might cause us some issues, but we have a calculator. Okay, so this is a non-standard form, so you always have to remember to make it into standard form. All right, so we identify A, that's 6, B is 11, C is negative 10. Wonderful. So I'll rewrite the formula here. Is anyone worried about having to remember the quadratic formula? Anybody? Nobody's worried about having to memorize that?
Yeah, I kind of am.
Okay, good. I'm glad you said that, because the point was going to be you don't have to memorize it. I will give you that formula on any quiz or exam if you need it. All right? No need to memorize formulas. That's my opinion, having been out in industry. Okay, so here we go. Let's plug some stuff in here. So we have negative 11 plus or minus the square root of 11 squared minus 4 times A times C over 2 times A. And really, the more you do of these, what's 11 squared? Anyone know? Is that 121? Yeah, 121.
Yeah.
And then we're going to add to this, what is it? That's 24 times 10, which is 240, but the negatives make it a plus, so it's 240. All over 12. So 121 plus 240, 361. Oh, that'll be fun. So we have to break up 361 if possible. Oh boy, let's see. 360, and all I'm doing right now is trying a bunch of different 361. Oh, maybe we can't break it up. Does anyone see anything how we could break that up? Would it be 81? Nope. 4. Nope. Gosh, is that a prime number?
Yeah, I think it comes out to be 19.
You can divide that by 19. Oh my God. So it's an actual, wow. I should have just did the square root of 361 on my cal. I didn't think that was an actual perfect root. So how about that? So you have negative 11 plus or minus 19 over 12. So we can actually get numbers here, right? If we had a square root, I would say we should leave it. So the first root's going to be, we'll do negative 11. I'll do the negative one first. Negative 11 minus 19 divided by 12. So what we're essentially going to get negative 30 over 12. We can simplify that in a little bit. And then negative 11 plus 19. So that's going to be 8 over 12. So if we simplified those, let's see, we could divide everything here by 6. So we'll have negative 5 halves. And then this one's divided by 4, 2/3. So there you go. X is negative 5 halves and 2/3. All right. That's it. So you just follow that process. I'm not entirely sure I need to do any more. I think that's probably enough because that's what's, that's it. It's pretty simple. So that actually ends section 1.3. So I'm going to give you a little homework assignment. Now I had already given you some, right? Let me just open this up here a little bit. If I go back, because what I'll do is I'll just include this. So I want to make sure I know what I did here. So I already gave you 19 to 23, 25 to 29, and 41 to 45. Because my plan right now is I'm just going to include those. So if you already did them, that's great. This homework assignment will be a little smaller. So this is homework for section 1.3, and this is on page 115 and 116, and they are already up on the D2L site. So if you need those, if you needed a picture of them, they're already there. So 19 to 23, 25 to 29, 41 to 45, okay? They were the ones I had already assigned, and I'm just going to add to it 47 to 69, and again, they're all going to be odd. And because it's Thursday and you have so much time, I'd like you to continue to practice these because we're going to have a quiz next week on how to solve quadratic equations, definitely on Thursday. So this is going to be put it in the Dropbox by Tuesday. All right, so this seems to be our normal routine. Thursday, whatever homework assignment I give you on Thursday, that's going to go in the Dropbox on Tuesday. Everyone good with that? Any questions up to this point? Perfect. Okay, so that ends section 1.3. So what I'll do is I'm going to start section 1.4, and then when we get to about, we'll only have about 10 more minutes of class. I'll give you some instructions for the quiz and then send that out to everyone. All right, so section 1.4. All right, section 1.4 is on complex numbers. Okay. All right, so there's a couple things we need to do before we talk about a complex number. I want to give you the definition of, what do we call this? We call this definition of I, and we call that the imaginary unit. Okay. I've been referencing this as we were talking about square roots, that if you had a square root that had a negative sign in it, we were sort of just saying, well, that's imaginary and we're ignoring it for now. But it turns out that if you wanted to take the square root of -1, that is what we're defining as the imaginary unit. So we're just making that definition here. So that means this. If I were to do I squared, that would be equal to me doing the square root of -1 squared, which would give me -1. All right, so this is a good property also to know, that -1 equals I squared, because we're going to see this come up in many of the problems that we're going to see today. Okay? So one simple example of solving a quadratic equation involving this imaginary unit would be something that looks like this. Let's just say you had x squared plus 1 equals 0. Right, so this, we wouldn't be able to factor this. We wouldn't be able to, I mean, you actually could factor it, but let's not go there just yet. But you could do this. You can move that -1 to the right-hand side, and then we're going to do the square root method, so you square both sides. So you get, now remember, when you take the square root, you get a plus or minus. It'd be the plus or minus the square root of I, or I'm sorry, the square root of -1. So our final solution for this quadratic equation would be plus or minus I. We never want to leave a negative underneath that square root. We always want to change that into an I when we're doing any types of calculations. All right. So does that make sense? Everyone is okay with my definition of I, the imaginary unit. Again, you've probably seen this at some point in your life. So it's just a definition. All right, so now that we're okay with this, let's define a complex number. All right, so a complex number looks like the following. Usually complex numbers, we like to call them variables z, right? Because we use x, y a lot for real numbers, so z. So you'll sometimes see me put a strike through the middle just so you don't think it's a 2. It looks like this, a plus bi. So this is our standard form for a complex number. So the a, all right, this is the real part. The bi is the complex part, or I'm sorry, the imaginary part. So all a complex number is a number that contains both a real part and an imaginary part. It's really that simple. Now, what we're going to have to learn how to do, and the same type of arithmetic, like in terms of addition, subtraction, multiplication, division, it all works the same with complex numbers. It just sometimes it gets a little messy, because we always want to have our final solutions to anything we do be in this standard form where we have the real part first plus the bi. Now, there is one caveat to how we like to describe this standard form. So, like, for example, if you had a variable, so I'll just call that the caveat for a second. If you had the square root of -b, all right, actually, we'll make this a little easier. Let's do 3 plus the square root of -b. All right, so we want to put this in standard form. All right, so we'll put this in standard form. It's going to be 3 plus, so I'll take this step by step. I would do the square root of b and then the square root of -1, right? You want to take out that -1 so we can insert this I. So this would look like 3 plus the square root of b I. Okay? So that's not actually preferred. The preferred way to write this would be 3 plus I square root of b. So if you have a square root ending up in your imaginary part, we always like to park the I variable in front of it. Now, if you were to give me this as an answer, I wouldn't mark it wrong, but just try to look at it in that form, just because it'll be easier to check answers in the back of the book. Okay? We're doing okay? All right, so I think this is good. I introduced you to the imaginary unit and we defined a complex number. So that's a really good primer for when we come back on Tuesday and basically go through this section. And it's a section on just learning how to work with these complex numbers. All right, so this is a good place to stop. So here's the deal for the quiz, right? What I need from all of you is while you're taking the quiz here, you're going to need to share your screen just so I can see that you're not, using other resources. Just like if we were in class, I'm looking at you in the classroom. So at this point, will everyone just share their screen? That way, I could just see everyone's there. I'll even share mine. All right, where am I? There. Oh, I'm still in the Death Star. There we go. Perfect. All right, I just want to check because what I'm going to do is I'm in my office. So on my office machine, I'm going to kick off this email to you. All right.
So how does this work? Do we just put it in a notebook and then take a picture and send it to you, or?
Yeah, I want you to do it exactly how you would submit a homework assignment, except I don't want you to put it in a Dropbox. You're just going to directly email to me. Because then what I'll do is when you email to me, I'll immediately respond and say received. That way I have it. I'm just looking to make sure. Did Eamon come in yet? Eamon is not here. Okay, so what I'll do is I'm going to email you the quiz right now. I already have the text of it here ready to go. And there's brief instructions in the email that basically say to make a PDF just like you would for a homework assignment. And let me just attach the quiz. I'll make sure not to attach the solution to the quiz. I'm sure you'd all love that. Let's see. Okay. And I say that I'd like you to email to me by 9:55 because that'll give you some extra time, to take your picture, send an email, and make sure everything works out. And now once you email it to me and I confirm, feel free to go. You don't have to stay in class, okay? So if I don't see you, have a great weekend. Stay safe. And next Tuesday is supposedly our last virtual day, and then we'll hopefully be back in the classroom next Thursday. Okay, so I just sent it. If anyone's not getting it, sometimes it takes a second or two in D2L. All right, I just got it because I went to myself. So if I just got it, you should also have received it. And just have at it.